Hello, students. So, we will start a new chapter, that is light. And in this lecture, we will introduce with the light energy and the reflection also we will discuss. Okay. So, let's move on. First, that is the introduction to light. What you are assuming like light. Suppose candle, what you have in your mind whenever you are just I'm uttering the term light, that you can first you have in your mind the light. Just a minute, please. Let me take the pen. Okay, light first you can find out sun, lighter, stars, your table lamp, and lightning, and also wood fire, firefly, candle, match. So all these things, these you can see in your daily life. You can see in your daily life, right? So light, that means this, with this term we are very much familiar with this term. With this term we are very much familiar, that is the light. Okay, so what is light? Here, light or visible light is an electromagnetic radiation within the portion of electromagnetic spectrum that is perceived by the human eye. So beyond the human eye, because we will discuss that thing, what is the visible spectrum? So there are visible light that has the wavelength of range 400 to 700 nanometer, and 1 nanometer, this is nothing but 10 to the power minus 9 meter. Okay, 1 nanometer, this is nothing but 10 to the power minus 9 meter. So the light or visible light, this is electromagnetic radiation within the portion of electromagnetic spectrum that is perceived by the human eye. Because if I cannot see, then I will not call that this is our light. So visible light, it has the wavelength is how much? 400 to 700 nanometer. So this is very much important. Visible light 400 to 700 nanometer, and 1 nanometer, that is 10 to the power minus 9 meter. Okay. The light might have been either emitted by the object or reflected by it. Now, one thing you can see, emitted, that means if you have the candle here, so it will emit the light, right? It will emit the light. And in case of LED also, it will emit the light, right? You need, at the time of Diwali, you can see all the LEDs that we have. So these are the light. Or you can see in your home also, so many bulbs are there, so many tube lights are there. So these will emit the light. And whenever you are seeing yourself in the mirror, that is the reflected light. That is the reflected light. Okay. Now some of the important terminologies related to the light we will study here. Light is the energy that enables us to see. Light is emitted from a source such as sun, or there may be other source also, like candle, like torch. So there are so many sources. And the word usually refers to visible light. Whenever we are calling light, that means visible light. And visible light, it has the 400 to 700 nanometer wavelength. And it is visible to the human eye and is responsible for the sense of sight. So sense of sight. Okay. So if sunlight that falls on this apple, so I can see this apple. Otherwise, I will not see the apple. Okay. So some important terminologies. What are these? Light is an energy, and light is emitted from the source such as sun, candle, torch, and matchstick. And light, that refers to here we are referring to the visible light, and visible light that gives us the sense of sight. Okay. Next, how do we see the object? Our eyes alone do not allow us to see. First, the light that will fall on the object and bounces off onto our eyes. That is how we perceive it. So this is the very simplest thing. This is the very simplest thing. In a simple way, if you want to see, you want to say this answer of this question, so you can say this: the light that falls on object, and then it will reflect back. Then it will reflect back. Now reflect back, or you can say that bounce back. You can say that bounce back to our eye. Okay, to our eye. Okay, so good eye. Okay, red. Okay, so eye, and then we can perceive the brain actually. It will perceive that what is the exact object, because the eye actually it cannot predict that what is the object. It is apple or it is pencil. It is table or it is you. All these things will be perceived by our brain. Okay. Now, sources of light, already I have told a lot of sources of light. Apart from this, if you can tell me, so I can write here all the name of the lights. But here you have also one thing, that tube lights you are using, and the main source of the light, this is the sun. Main source of the light, this is the sun. An important source of light in earlier, when you were ancient India, so India, or it may be at that time, you can see that the humans, they are using the fires, and they are using the fires as a source of light, and also as a signal, right? Is a danger signal, then they are going to fire. Okay, so they are using the fire. So here, that means they can use. And in our childhood time, we have seen one thing, I don't know you have seen or not, kerosene lamps you can see. And with the development of electricity, after that, what we are seeing, that electric lighting and effectively replaced by firelight. The firelight already it has been replaced, and now we are using the electric light. Okay. And if you are moving through any village area at that time, or remote area, at that time you can see the firefly. You can see the firefly. This is also a source of the light. Now the reflection. So here, the process reflection means the process through which light rays fall on the surface and get bounced back is known as reflection of light. So the process through which light rays, in this left picture you can see that the light ray falls, these blue lines, and then it will reflect back as the red lines. So the process through which light rays fall on the surface and get bounced back is known as the reflection of light. So here you can see that light rays, if this is the surface and there is an incident light, if light rays fall, this is called incident light, and again it will bounce back. At that time, it is called the reflection. This is the reflection of light. Okay. Light get reflected off surfaces. Any surface that is really well polished or shiny acts as mirror. Acts as mirror. But one thing you should know, whatever the mirror you are using, there is a coating. One side that is coated, and another side that is the glass material. Now, the phenomenon of light bouncing off sources is called the reflection. So, in this picture, you can see that this light is incoming and then it is striking with this mirror, and at this point it will striking again, it will bounce back to the same medium. So let this is the air medium. So from air, through the air, the light is incident on the mirror, then it will bounce back. So again it will come to the air medium. So this is the reflection. Now here you can see that if this is a very smooth surface, if this is a very smooth surface, then it's specular reflection and this is the diffuse reflection. I will discuss these two things. So let's proceed. Now types of reflection. First one is the regular reflection. A plane mirrors with a smooth surface produce this type of reflection. So this is the plane mirror and smooth surface. This is the plane mirror and smooth surface. And if this is the plane mirror, in this case, regular reflection will occur and the image is clear and very much visible. The images produced by plane mirrors are always virtual. That is, they cannot be collected on a screen. So here you can see that all the parallel rays of the light, it is just incident on this, falls on it and it will bounce back in the same medium. So light rays reflected in one direction only. So this is the smooth surface. Okay, smooth surface, reflection on the smooth surface. So this is the smooth reflection. Now images produced by the plane mirrors are always virtual and that is they cannot be collected on a screen. That we'll understand later on. Irregular reflection. Now suppose the surface is not smooth and it is like this. So what happens if this will the falls, this ray will fall, then it will reflect back like this. But if this will fall here, at that time, this will reflect like this. If any ray that will fall here, you can see that any ray it will fall here, then it will reflect back this, like this. So that means whatever the rays that has been bounced back, these rays, they are not parallel to each other. They are not parallel to each other. Here you can see this ray, this ray, this ray, this ray. They are not parallel to each other, but the light rays which falls on the surface, they are parallel. But the bounce back rays, these are not parallel. So this is the irregular reflection. So parallel incident light rays are reflected in many different directions irregularly or diffusely. So that is called diffuse reflection or irregular reflection. And diffuse reflection helps in seeing the objects and is responsible for the ability to see most illuminated surfaces from any position. You can see the wall, you can see you can see the fan, you can see the lights. So due to the irregular reflections, you can see all these things, right? Clear? So there are two types of reflections here we have studied. One is the regular reflection. Another is the irregular reflection. Okay. Regular reflection, in case of mirror, you can see the regular reflection. And here in case of other objects which have not smooth surface, this will cause the irregular reflection. Now laws of reflection. So before laws of reflection, I want to introduce you with different terms. First is the incident ray. Okay. Now incident ray, if this is the surface and the light falls this one, this is called incident ray. Incident ray. Clear? Then next term, this is the reflected ray. It will bounce back to the same medium, so it is called reflected ray. This point point of incidence. Let this point is the P. At which point incident ray strikes, this is called point of incidence. And if I draw a normal, that means 90-degree with the surface, then this is the normal. Like this one is the normal. Okay. So this one is the normal. This point is the point of incidence. This is the incident ray. Just a minute. Incident ray. And this one is the reflected ray. Okay. And if in this plane, light is incident, so this is called plane. This is called the plane. So in the laws of reflection, the ray of light, that strikes a reflecting surface is called incident ray, and the ray that gets reflected back is called reflected ray. The imaginary line that is perpendicular to the reflecting surface is called normal. So these definitions are very important before going to the laws of reflection. So let's move on. Laws of reflection. The angle of incidence I. So this is the angle of incidence. That means the angle of incidence. First I am telling you angle of incidence. This is the angle between incident. Now we know the incident ray. So angle between incident ray and normal is called incident angle. Then angle of reflection, angle between reflected ray and normal is called reflected angle or angle of reflection. So this is the angle of reflection and this is the angle of incident, right? An angle of incident that is denoted by I, this is angle of incidence, R, angle of reflection. So the angle of incidence I and the angle of incident I and angle of reflection we have understood. Now we will see what is the laws of reflection. Now laws of reflection, the angle of incidence I is always equal to angle of reflection R. The angle of incidence, angle of reflection, normal all lie in the same plane. So first part of the law, that is angle of incidence, that equals to angle of reflection R. And second part, always you have to say along with the first part, that is the angle of incidence, angle of reflection and normal, these three all lie in a same plane. All lie in a same plane. Okay. Now, what is law of reflection? So, the principle when the light rays fall on smooth surface, the angle of reflection is equal to angle of incidence. Also, the incident ray and reflected ray and the normal to the surface all lie in the same plane. This is the law of reflection. Now, what is the angle of reflection? So, angle of reflection of the ray is the angle measured from the reflected ray to the normal surface. Now, one thing I want to say you, suppose it has been given, this is the normal, this is the incident ray, this is the reflected. Let me write reflected ray, incident ray. Now, if this angle, they have given suppose 35 degrees. So according to law of reflection, angle, incident angle that equal to reflected angle. So this will be 35. Now another type of question may come. This is normal. This is incident. I am denoting with R. This is reflected. Now suppose this is 60 degree. Right? Now they can ask you how much is the reflected angle. So they can ask you how much is the reflected angle. So if this is 60 degree, because this is the 90 degree, total is 90 degree, normal and the surface. This is the surface. So normal and surface you have 90 degree. That means this will be our 30 degree. So this will be our 30 degree because angle of incident that equals to angle of reflection. Angle of reflection, right? So now you are able to find out what is the incident angle, what is the angle of incidence, what is the angle of reflection if any one of them has been given to you. Clear? Now calculation of angle of incidence and angulation of angle of reflection. So here in this example it has been seen this is 45 degree. Now according to law of reflection, angle of incident equal to angle of reflection. So theta I that equals to theta R. That means if theta I equals to 45 degree, theta R that equals to 45 degree. So it will be our 45. Clear? Now the key points. Till now, whatever we have studied, just we are going through all these points. The ray of light that hits the polished surface is called the incident ray. And the ray of that gets reflected or bounce back away, that is bounce back, that is called the reflected ray. The point at which the light hits this point, this is the point, this is the point, this is called point of point P, point of incidence, point of incidence. The point at which the light hits the surface is called the point of incidence. And if a line drawn perpendicular to the surface or to the point, to this point, at this point, if it is perpendicular 90 degree, then this is called the normal. This is called the normal. Okay. So if I draw one imaginary line that is perpendicular to the plane mirror, perpendicular to this surface, then it will be our normal. It will be our normal. Now, what is the angle of incidence? The incident ray, reflected ray form two angles at point of incidence, and the angle formed between the normal and incident ray, that is called angle of incidence, and angle formed between normal and the reflected ray, that is called angle of reflection. Already we have studied just for the brush up, we are just pointing out these things. So angle of incident that we are measuring as I, we are denote symbolizing with I, and that equals to R. Already we know this thing. That means angle of incidence that equals to angle of reflection. Okay. Now angle of incidence formula. So angle of incidence is equal to angle of reflection. Already we know that thing, theta r. So suppose this is the surface and this is your I and incident angle. Now one normal you are drawing. This one is the reflected. So this is our theta I and this is our theta r. Okay. So angle of incidence and the angle of reflection is always equal and they are both on the same plane along with the normal. So according to the law of reflection, the second part I have told you, no, the second part, that is the angle of the angle of incidence and angle of reflection both are same, equal, and they are both same on the same plane. The angle of incident, what are the in the same plane? That is the incident ray, reflected ray, and normal all lie in a same plane. Okay, this is the second part of the laws of reflection. Now, suppose one example here. Consider a light ray which is incident on a flat surface and it has 10 degree. So now you know that this total angle is 90 degree. Okay. So if this total is 90 degree, at that time, if now this one is only 10 degree, how much is this one? This is 80 degree. So here that means the angle of incidence that equal to 80 degree. Okay. How it comes? That is 90 degree minus 10 degree. That is the 80 degree. Clear? Now here you can see this one. In this case 80 degree. So if they will ask, this will be straight line. I have drawn a very bad diagram. Okay. So if this is the normal, if this one is 80 degree, this one will be 80 degree. Why? Because theta I that equals to theta r according to law of reflection. According to law of reflection. Okay. So here we can do one thing. We know that normal to the surface is always 90 degree. So first draw a normal to the surface. Then you can find out that theta I that equals to theta r. Okay. Next, the angle at which light rays strikes and reflected plane surface is 56 degree. 56 degree. So what will be our, here the question is that what will be our different parameters you have to find out in this question. Here let me change the pointer color. Okay, so solution, first one, angle of incidence. So if it is 56 degree, this total angle, this is the 90 degree, right? That means angle of incidence that equals to 90 degree minus 56 degree. 34 degree. Number 2, angle of reflection that equal to angle of incidence. So this is also 34 degree. Then angle made by reflected ray and the surface. So angle made by the reflected ray and surface, that equals to, this total is also 90 degree. Now if it is your 34 degree, this is also 34 degree. So this will be 90 degree minus 34 degree, that equals to 56 degree. Okay. The angle made by the incident and reflected rays. The angle made by incident and reflected rays, here I am writing twice into 34 degree. So how much it will be? 68 degree. Okay. So this is the answer. This one is the answer. Clear? Is it clear? Fine. Now let's proceed to the next one. What is the relationship between angle of incidence and angle of reflection? So first let me change the ink color. Okay. When light passes from one medium to another, now what happens? I am drawing here. So this was the mirror, right? This was the mirror. And mirror is made up of glass. Made up of glass material. Now, from the medium air, through the medium air, the incident ray is falls on the surface mirror and it will reflect it back to the air medium. So when light passes from one medium to another with different densities to another different density, path gets deviated. This phenomena is called refraction of light. This is called refraction of light. Okay. So incident ray, refracted ray, normal, point of incidence, these points are very important. So the angle of incidence and angle of refraction. So now this was the reflection. That means here you can see that it will be reflected back. Another thing will happen. Suppose you have one glass medium here or water medium. Suppose water or glass, whatever. And there is air medium here and incident, then it will be, you can see that here you have the normal here and you can see there will be some deviation. There will be some deviation. So there will be some deviation. It will penetrate inside this medium and there will be some deviation. And here you can, this is called the refraction. So angle formed at the point of incidence between incident ray and the normal, this is called angle of incidence, and angle formed between the refracted ray and the normal, it is called angle of refraction. So what is refraction? First we have to know that thing. Refraction, this is the bending of the wave. You can see if there is medium 2, medium 1. So if this is incident ray and this is the normal, this is incident ray. So you can see that it will move like this, bending like this. So this is refracted ray. I am not telling reflection, I am telling refraction. Okay. So refraction is the bending of wave when it passes from one medium to another medium. And the bending is caused to the differences in densities between the two media. So whatever the density of medium 1 and medium 2, the bending depends on that thing. Now definition of diffraction, you can say this, refraction is the change in the direction of a wave passing from one medium to another. So diffraction is the change in direction of the wave. Here you can see the direction has been changed. The wave actually, whenever it will penetrate, this is the normal path. This should be the normal path, but now it is not going through this path. So it has changed the path. So the direction, it has changed the direction. So refraction is the change in the direction of wave passing from one medium to another. Passing from one medium to another. Okay. Now, refraction makes it possible for us to have optical instruments such as magnifying glass, lenses, prisms. So, we can use this refraction. Now, it is also because of refraction light that we are able to focus the light on our retina. So, due to refraction, we can see with our eye. Now, here you can see that the stars are in a very distant area and space, and refraction will occur because this is the earth, and this here you have the star, here you have the star, right? Here you have the star. Now what happens, here you have the star. Now what happens, there are so many layers, there is so many layers of the atmosphere. So these are the layers of the atmosphere, and due to every layer there will be some refraction. So there will be some refraction whenever light comes from this. You can see that there will be some bending here, there will be some bending here, then there will be some bending here, then there will be some bending here. So you can see that there is a bending in this all these layers. We have different layers, and for different layers the densities are different. Densities are different. So here you can see that due to the refraction, we can see the light, that we can see the twinkling, twinkling star, twinkle, twinkle, little star. Also, we can see some instruments using the magnifying glasses, lenses, prisms also. In prisms also we can see some different types, different colors of the light from a white light. So due to the refraction. So why do stars twinkle, that I am describing in that thing. So when a ray light travels from one medium to another, it bends. So this we have understood from the refraction. Okay, from the refraction. Okay, if it will come from one medium to another medium, due to the density difference in the density, it will bend, and this phenomena is referred to as the refraction. Now, if it travels from rare medium to dense medium, it bends towards the normal. I am writing here. This is medium 1. This is medium 2. This is here. Density is low, rare medium. And here this is dense. Okay. This one is dense medium. Now, whenever there is incident light, you can see that it bends towards the normal. It bends towards the normal. That means it is coming towards the normal. And whenever it will go from, I am drawing here, whenever this is the normal, if it is dense and it is rare, then it is moving out from here. That means it is moving away from the normal. So when it travels from a dense medium to rarer medium, you can see that it bends away from the normal. That speed at which the light travels changes depending on the medium, and therefore this bending occurs. And this effect can be observed when light passes through a prism or a glass slab even when light passes through water. So if one light will passes from air to water, there will be a bending. If water to air again, there will be a bending. Water to air, again there will be a bending here. So you can see that there will be different bending and it depends on the densities of the medium. And this effect can be observed when light passes through a prism or glass slab, even when light passes through water. The light ray travels from air to medium of different densities here. Okay. So the detailed reason that will be the atmospheric, the different layers of the atmosphere. So here you can see that the atmosphere of the earth is made of different layers and it is affected by winds, varying temperature, different densities as well. So when light from a distant source, a star passes through our turbulent atmosphere, that is moving air, it undergoes refraction many times. And when we finally perceive this light from a star, it appears twinkling. And this is because some light rays reach us directly, some bends away. That means after some bends away from and towards us, it happens so fast that it gives us twinkling effect. Okay, so that's why there is a twinkling twinkle little star. Thank you all. With this, up to this much for today. Thank you.